again. All right. Problem number 7 on our sheet this week, we have a question which says, describe the effect of pH on pH. Will it increase pH, decrease pH, or have no effect on the pH when you take some salts? We've been talking about salts, and you take a salt and you throw it into a solution of acid or base. So here, and I'm looking at A, we have acetic acid, and the equation for acetic acid is acetic acid a strong acid? Very good, Billy. Very good. Thank you for listening. No, it's not. It's not one of the strong acids, so therefore it's got to be weak acid. Weak. Okay. So now, therefore, because it's weak, we have our arrows going both ways. We have an equilibrium set up. So we have acetic acid breaking down to the acetate ion and a hydrogen. All right? Okay. Now, here's what we got. This thing is all just hanging. It's all good. It's happy. Its equilibrium's been established, which we remember means as much stuff going this way as going this way. As many people going in Walmart as coming out of Walmart, equilibrium has been established. So we have equilibrium. Everything's happy. Everything's floating along. Such a good time. Yeah, everything's good. Don't bust my bubble. All right. I should write music. Now, but you decide to bust the bubble. You decide, because it's the way you are, you're going to throw some, let's see, potassium acetate into the solution. So you decide to throw some potassium acetate into the solution. Potassium acetate is a salt. Any potassium ion salt is really soluble, so it's going to break down. Potassium acetate will break down into potassium ions and acetate ions. When it's put into the water, into this solution, it was all nice and happy and minding its own business until you came along and screwed up its world. All right, now, when I do this, the potassium has no effect on this up here. I mean, it's not in the equation. It's not going to do anything. So we don't care what you are. You don't matter. But you do. You matter. You're acetate ion. And what you just did by adding this salt with the acetate ion in it to this reaction which had an acetate ion in it, it's called the common ion effect, hence common ion, which will have an effect, common ion effect. This is actually leading us into buffers, which is something we'll be talking about in the next class. So common ion thrown into the solution. Le Chatelier's principle. Remember that guy, Le Chatelier? Le Chatelier. I think it's Italian. Okay. Yeah, that Italian guy. Now, if we throw this in, it stresses this side out. Actually, the whole thing freaks out. The whole thing says, what are you doing? What are you doing? You're dumping a whole bunch of this stuff in. You're making this stuff in abundance. This thing freaks out. You just stress the reaction out. So now the reaction goes, must decrease acetate ion. Too much acetate ion, must decrease it. Well, how are you going to do that? The way you're going to do that is you're going to reconnect some of these acetate ions with the hydrogens to get this stuff to pull to the left. You're going to shift the equilibrium to the left. You're going to connect, because you have so many acetate ions now in the solution, you need to reconnect some of those with hydrogen to get rid of them, to get back into equilibrium again. Get those things out of there, man. Reconnect with hydrogen, reform the acetic acid. Now think about that for a second. If you have to connect hydrogens to the acetate ion to reconnect and make some of these, to get rid of these, you're losing hydrogen. You lose hydrogen, you are becoming less acidic. So the pH, remember pH, acids below 7. So if you're losing hydrogen and becoming less acidic, the pH must be boop, 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 going up. The pH will rise to a higher number. The pH of the solution was, we don't know the concentrations, but maybe it was like pH of 4. We got to pull hydrogens out to deal with the intruder. That means I'm not going to have as many hydrogens left. That means my pH is going to be less acidic, which means more basic, which means pH is going to rise. Okay? So pH goes up. Now, I'm not going to go through every one of these. You try to figure some of these out. Well, let's do another one. We'll do one more. Let's just pick one out of here. Oh, I missed the paper. Try again. Oh, yeah, I got one. All right, I'm looking at C. Sodium formate to formic acid. All right, so formic acid. Well, that's going to form some COO. Well, I'll put the H here. That H will keep it. This one will pop that one off. Positive. Okay, so we have an equilibrium established. Now what you're going to do, you're going to take some salt. You're going to take some sodium formate. Okay, some sodium formate. You're going to throw that into the solution. It was nice and happy. You came along and screwed it all up. Nice job. All right, so you throw some sodium formate. Any sodium solution is extremely soluble, breaks right down. You can see that that's not involved in the reaction. It doesn't matter what that is. It's a common ion in the reaction. So by doing this, throw that in there, you end up freaking this thing out, and this thing says, we gotta get rid of those. How are we gonna get rid of those? Connect them with H's, toss them to the left, make more of this, so you can get rid of that. So we lose hydrogen, pH drops. I'm sorry, H drops and pH rises as a result of that. It's the same as the other one. Try a few of these on your own and see what you come up with. The answers are written out there for you. See if you can get those as well. Think about what you're doing. You're adding a common ion into the solution. And what happens to balance the solution out, you got to shift stuff to the left. And if you're shifting stuff to the left, you're pulling H's out, pH goes up. If you're pulling OH's out, pH drops. All right? Give them a shot. I have faith in you.